Introduction to iron prospecting. Iron prospecting is a key aspect of mineral exploration, focusing on one of the Earth's most abundant and industrially vital elements. Iron, abundant in the Earth's crust, is essential for producing pig iron and steel, with nearly all mined iron ore used in steel production. Understanding iron prospecting techniques is crucial for raising awareness about mineral exploration and inspiring future geologists and prospectors. This guide provides a concise resource for creating engaging YouTube content to educate viewers on iron prospecting. Where to look for iron ore. Geological settings and formation types. Iron ore deposits form in diverse geological settings, from ancient sedimentary rocks to hydrothermal systems. The most significant deposits are found in banded iron formations (BIFs), which dominate global iron ore resources. These Precambrian sedimentary rocks feature alternating layers of iron oxides, magnetite and hematite, and iron porchert, creating a banded appearance with silver to black iron oxides and redshirt layers. BIFs can span hundreds of kilometers and reach thicknesses of several hundred meters, typically containing about 30% iron, making them economically viable for mining. Primary target areas. Prospectors should focus on specific geological and topographic settings. Precambrian shield areas. These ancient terrains host the most productive iron ore deposits, particularly BIFs. Key regions include the Superior Iron Range in North America, the Pilbara in Australia, and areas in Brazil and Russia. Structural controls. Look for intersections of strike and cross faults, synclinal structures where ore bodies often form, thrust faults that repeat iron formations, steep dipping beds which are more likely to show enrichment. Topographic indicators. Enrichment occurs on ridge flanks rather than crests, and increasingly in valleys, especially in northern regions. Surface indicators and signposts. Surface clues guide prospectors to potential iron ore deposits. Coloration patterns. Yellow and orange limenitic hues on slopes suggest iron oxide weathering. Blue hematitic coloration is a positive sign. Red coloration, while iron-related, may not indicate high-grade ore. Gossan formation. Iron-rich gossans, oxidized caps over sulfide deposits, are reliable indicators. They form boxwork textures with red to black colors, resisting erosion and signaling underlying mineralization. How to identify potential iron-bearing rocks. Primary iron ore minerals. Identifying iron ore minerals is essential for prospecting. Magnetite, 72.4% iron content. Black, opaque, metallic luster, naturally magnetic, producing a black streak. Hardness of 5.5–6.5, specific gravity of 5.2 feels heavy. Hematite, 69.9% iron content. Brown to black or silver, with metallic to dull luster. Rust red streak, non-magnetic. Hardness of 5.5–6.5. Goethite, 62.9% iron content. Brownish yellow to dark brown. Red streak. Limonite, 55 iron content. Yellow to dark brown. Red-brown streak. Field identification techniques. Simple tests aid field identification. Streak test. Scrape the mineral on a white ceramic tile. Hematite, goethite, and limonite produce red to red-brown streaks. Magnetite yields a dark gray to black streak. Magnetic testing. Use a hand magnet or compass to detect magnetite's magnetism, which deflects a compass needle. Hardness testing. Iron minerals. Hardness 5.5–6.5–6.5 can scratch glass but not quartz. Test with a steel nail or glass. Physical appearance. Iron-rich rocks are heavy, dark gray to reddish-brown, often with coarse crystalline or banded textures. Advanced identification methods. Geophysical techniques. Magnetic surveys. Magnetite's magnetism makes aeromagnetic and ground-based surveys effective for detecting iron ore. Gravity surveys. Dense iron rocks create gravity anomalies, ideal for large ore bodies. Integrated approaches. Combine magnetic and electrical surveys for better accuracy. Portable technology. Portable X-surf. Handheld X-ray fluorescence analyzers measure iron content in seconds. Portable XD. Mobile X-ray diffraction identifies iron mineral phases down to 1% concentration. Exploration methodology: systematic prospecting approach. Regional reconnaissance, map geology and review surveys to identify target areas based on regional geology and known iron occurrences. Detailed ground surveys, traverse target areas, collecting rock samples and mapping color anomalies, gaussons, and structures. Trenching and pitting, excavate shallow trenches to expose fresh rock, assessing mineralization continuity. Drilling programs, use diamond drilling to evaluate deposit extent and grade at depth. Sampling and analysis: sample collection, collect representative samples systematically along structures and mineralized zones. Sample preparation, crush and reduce samples, maintaining security and chain of custody. Quality control, use blanks, duplicates, and reference materials for analytical accuracy. YouTube content strategy: educational content structure, create engaging YouTube videos around these themes. Foundational knowledge, explain iron ore formation and geological settings using visual aids like animations. Field demonstration, show streak tests, magnetic testing, and other techniques with real specimens. Equipment and tools, highlight tools like hand magnets, streak plates, and geological hammers, explaining their roles. Case studies, discuss major iron ore discoveries, detailing geological and exploration methods. Engaging visual elements, before and after comparisons, contrast weathered outcrops with fresh surfaces to show mineral content differences. Microscopic views, display crystal structures and textures of iron minerals. Maps and diagrams, use geological maps and cross-sections to illustrate ore deposit structures. Safety and environmental considerations: field safety protocols, wear safety glasses, hard hats, and steel-toed boots. Share planned routes and return times with others. Carry emergency communication devices in remote areas. Environmental responsibility, obtain permits and respect property rights. Follow leave no trace principles. Close test pits to prevent hazards. Legal considerations, research local mining laws, as permits are often required, and mineral rights may differ from surface rights. Conclusion: iron prospecting combines geological knowledge with modern techniques to locate vital iron ore deposits. Success depends on understanding geological settings, recognizing surface indicators, using field identification methods, and following systematic exploration. YouTube creators can produce educational content with practical demonstrations and engaging visuals to inspire future geoscientists. By focusing on specific geological environments and responsible practices, prospectors and educators can contribute to the discovery and appreciation of this critical mineral.
Are you passionate about geology and earth sciences? Explore geology with me on YouTube. Subscribe, like, and share my content.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.